minus 2ix minus x plus 2ix. And the multiplication, this is 1 times 1, que es 1. 1 times 2i is 2i. This is minus 2i. Always happen que, okay, entonces you have minus 4i squared. Always happen que the imaginary part is gone. When you multiply any complex number times its conjugate, this is a special problem. And the answer is real. Entonces, in this case, I know that I squared negative 1. This is negative 1 and this negative 1 become positive. Entonces, 1 plus 4 is 5. F5 plus 5. And also, this part is gone. And we combine like terms. So we have x squared minus 2x and plus 5. No? This is the answer for the first two complex. That when you put together, unbelievable, amazing, we get the polynomial with the real coefficients, you know. So the I disappear. They disappear because the idea behind is the complex solution, the complex zero, the complex root, whatever you want to call, is conjugate. However, we have another, no? We have another que es the real part. The real part is x plus 1 times x minus 2. Okay? Using negative 1, using positive 2, however, in the factory, you copy in the opposite sign, and you FOIL here, x squared minus x minus 2. Entonces, actually, the last step, I want to skip, is multiplication, this and this. So you no FOIL because we have 1, 2, 3, 1, 2, 3, 9 combination. But well, okay. Finally, you obtain after when you combine later this answer: x to the 4th power minus 3x to the cubed power plus 5 x to the 2nd power minus x minus 10. Que es the option C. So you understand, no? Multiplication this and this is too long. Wow. Any question? Super confusing or super clear?
Can you do another example?
Of course, we have a lot of. We are doing, okay, last class, we are doing 48, que es similar to this. Now we are doing 49, we have 50, 51, and let me see. 50 and 51, que es similar, very, very similar. Okay? Okay, I forgot to record, no? Or no? Carajo. No, somebody help me. Oh, good. Okay. Who help me? César, no? Yamin. Who start recording?
F is recording the call?
Yeah,
I don't know who that is.
You don't? Frank. Thank you, Frank. Okay, guys, let's move on to the 50. No problem. 50 is easy. Wow. Why? Because 50 say that we have polynomial degree 4, 50. 50 is degree 4, polynomial degree 4. Degree 4. However, we have 4i, the 0 is 4i, and minus 5i. Okay, the 0 is given is pure imaginary. Because I infer that the other 0 is a conjugate of this guy is minus 4i and positive 5i. Make sense? Make sense? Remember, conjugate, complex number contain real part and imaginary part. A conjugate is a minus ib. But in this particular example, we are working with the pure imaginary. Pure imaginary means Okay, we have no real part. So you consider, for example, 0 plus 4i. And the conjugate is 0 minus 4i. Or just negative 4. Okay, entonces bueno, the factorization is actually, I want to do at least one only, que es x minus 4i multiplication by x plus 4i. Pero actually, well, let's do it. I don't know. You multiply this and this is x squared. You multiply this and this, 4i plus 4i x. You multiply this and this is minus 4ix, and you multiply this and this is minus 16i squared. One more time happen, okay, this is cancelled, and this is the famous x squared plus 16, because I squared is negative and double negative become positive. Wow, and this is expecting, very, very expecting. This is typical sum of the square. Okay, you know, in algebra, okay, this is prime expression, and the reason que prime expression is clear because when you break it down in factor linear, so degree 1, we have complex number or imaginary number. And this is called sometimes irreducible quadratic expression. Irreducible quadratic expression. Likewise, the second guy, que is phi I and negative phi I, should be x squared plus 25. By the same reason, no? Now, finally, you multiply here, you FOIL. You have x to the 4th power plus 41, x to the 2nd power plus 400. When you FOIL this, x times x to the 4th power, 25, x to the 2nd power, 16, and 16 plus 25, 41, and multiplication 16 times 25, 400. End the story. Option D. Any question? That was clear or confusing?
It's clear.
It's clear. Very well. Let's do one more, miss. Okay, no, 51. 51 is, well, 51 we have, okay, 51 is easy. Look, I like that. Okay, 51. 51. We have, it's given degree 4 again. It's given the corresponding zeros or root, whatever you want to call it. Okay, is 1, negative 1, 2 real, and 1 complex, que es 4 plus 2i, minus 2i, sorry. Entonces ahí immediately infer que the number 4, 0 is 4 plus 2i. In total we have 4, que is exactly corresponding with the degree of the polynomial, no? Que is exactly the fundamental theorem of algebra say que the root or the zeros of the polynomial equation is exactly the same with the degree. So you count the complex and the real que have, you know, multiplicity different to the 1, no? In this case, no. In this case, is 1 positive 1, multiplicity 1, negative 1, multiplicity 1, and 4 minus 2i and 4 plus 2i. Okay, so we are doing the famous multiplication que I am boring to do, que es x minus parenthesis 4. This is important, the organization, guys. Okay, the format of the factor of the polynomial is x minus something. And this something, it doesn't matter if it's real or it's complex. Si it's complex, I recommend you enclose in the parenthesis because this minus of the factor affect everything inside the complex number, no? Entonces, x minus 4 plus 2i. It doesn't matter if you start for this or you start for this. O sea, suppose now the real part. The real part is x minus 1. Why do you put in black space for the test? I don't know what you're talking about. Black space of the test. When the class is over, let's see what is the black space of the test. We have x minus 1. Okay, guys, we focus now on the problem we are doing now. The test or another situation after the class, maybe you stay. No, stay no, because I have another class. You email me. Yeah, I explain by email. And x plus 1. Do you understand this or no? Okay, this is the factors que corresponde with the real part. This real part. And this is the factors que corresponde with the complex part. And by the way, the multiplication, this is super easy. It's x squared minus 1. It's the typical differences of the square. When you fold this, you get that. And when you fold that, okay, I don't want to do it again because it's the same thing. I got x squared minus ax plus 20. So finally, multiplication this, multiplication by that, and the answer was x to the 4th power minus 8 x to the 3rd power plus 19 x to the 2nd power plus ax minus 20, que es the option B, like so. Okay, I do fast because I consider that we know that this is just long, no complication, but it's long and consuming time. Everything clear or confusing?
It's clear.
Okay, guys. Let's go to the 52, 53, 54, 55, 56, and 57, que basically is find all zero of the function and write the polynomial as a factor of linear. Oh, this is the same thing, but a little bit different. Let's practice. For example, 52. 52 is y equal x cubic minus x squared plus 16 x minus 16. Okay, now immediately I try. You can do by factorization or you try by synthetic division, no? Okay, one fantastic way is when you face that problem, don't waste the time. You go to decimals, you do the graph, and you can see we have one real zero. In this case, the real zero is in 1. I saw in decimals, que es at x equal 1. Entonces you perform synthetic division. 1 negative 1, 16 negative 16, and you divide it by 1. Okay, bring down 1. 1 times 1 is 1. This is 0. 0 times 1 is 0. 16. 16 times 1 is 16. Remain the 0, and you prove okay, the factor x minus 1 belongs to this. The other factor, well, this is x to the 0, this is x to the 1, and this is x to the 2nd. The remaining part is x to the 2nd plus 16. Okay, this is obvious. Okay, this is factorization. End the story. I finish. However, they want can you express it like a product of linear. And this is not linear. This is quadratic. So this is not the answer they want. They want can you break it down this in complex field like that. Well, x minus 1 just bring down. This is xx, and this is 4i, and this is 4i, plus or minus. End the story. This is the answer they want. Okay, the option A, no? Good or no? How do you know? 4i. Okay. Okay, one more time. I want to explain this. Look. Well, I know for 2 reasons. Reason number 1, see you enforce it to be 0, this expression. The solution of this is minus x equal plus or minus 4i. So this is give me a clue. However, let me try to foil that part. X times x squared. X times negative 4i is minus 4i x. 4i times x is plus 4i x. And 4i times negative 4 is negative 16i squared. This is always cancelled. No imaginary anymore. Real coefficiency, and we have x squared. I know that I squared is negative 1. And negative 1, another negative become positive. End the story. It's a factorization. Super clear or super confusing? Okay, makes sense. Okay, of course makes sense. Okay, this was 50, 50, 52, no? 52, okay. 52, let's go 53. 53, 53. 53 is y equal x cubed plus 11 x squared plus 36 x plus 26. Okay, in this moment, we're using every resource that we have. We have factorization, we have synthetic division, and also we have decimals. Entonces I put in decimals, and decimal is graphic. Entonces, decimal, give me the information, the real zero that we have. Entonces I can see in decimals que negative 1 at x equal negative 1, we have 1, 0. Okay, entonces I perform synthetic division because factorization I suppose que es impossible. 1, 11, 36, 26. Y I do the synthetic division using negative 1. Bring down 1, multiplication is negative 1, this is 10, multiplication is negative 10. This is 26, multiplication is minus 26, 0. Entonces I prove algebraically que the factor x plus 1 belong to the polynomial. Remember, in the factor, the typical format for the factor is x minus something. And something in our example is negative 1. Entonces negative 1 and negative 1 become positive. Okay, now I have no idea. Now what's going on? What is the next factor? Well, no, in decimal I see only one real. That means that the rest maybe should be or must be complex. Entonces this is x to the 0. This is x to the 1. This is x to the second, no? So basically this expression is x to the second plus 10x plus 26. Now I using the quadratic formula maybe, no? To find the solution of this guy is, you know, A is 1, B is positive 10, and C is positive 26. Is minus 10 plus or minus square root 10 squared minus 4 times 1 times 26 divided by 2 times 1. Okay, I focus in the expression inside the radical, this expression. Okay, here is 100. And 26 times 4 is 26. I put in my calculator. 104. Wow, 104, 104. And 104 is minus 4. And square root negative 4 is 2i. Well, actually it's plus or minus 2i, no? So we have minus 10 plus or minus 2i divided by 2. So these two, if you want, split. Because it's a complex solution to say I want to express it in, you know, this is the real part, and we have the imaginary part gets 2i. Okay, so what is the final answer? The final answer is you have degree 3. You have 3 factors. The first one is x plus 1. And the second is x minus c. And we have 2 c complex, minus 5 plus I and minus 5 minus I. Entonces, bueno, one way to do is open the parenthesis. I like so much. Minus 5 plus I. And this is a bracket, no? Another bracket, entonces x minus parenthesis negative 5 minus I, no? And I leave it like that, no. No, much better. This is perfect, no? However, much better is remove this parenthesis and you have x plus 1, x plus 5 minus I, no? You distribute the property, this negative 1 here. And x plus 5 plus I. End the story. It's the final answer, que es the option A. Let me see. Check it out. 53. I guess so. Yeah. Any question? How do you feel? No. How do you feel? You consider it necessary to do 53? 53 I did, no? 54, 55, 56, and 57, que es the same. Cara dice, yes. Cara dice, yes, professor. Okay, do everything. Pero everything or one more or two more or all of them. One more, Cara dice, no, okay. Are you agree, guys, or disagree? Okay, one more, 54. Agree. One more, and that's it. It's the same stupid thing. Okay, 54. Stupid 54. Okay, 54 is y equal x cubed plus 8 x squared plus 24x plus 24. Wow. Y I saw in Desmos. I saw in Desmos que we have one real zero, que es at x equal -2. I saw in Desmos. See, I don't use in Desmos, so I consuming a lot of time try the combination for the rational zero. This is crazy, and you know that this is not always enough. Okay, so we are doing the scientific division. 1a 24, and you divide by -2. Bring down 1 and -2 is 6. Multiplication is -12. This is 12, positive 12, and positive 12 times 2 is -24. Good. I prove algebraically uses scientific division que x plus 2 is a factor. And the rest is x is 0, x1, x squared, so x squared plus 6x plus 12. Well, in this case, using again quadratic formula, maybe, because factorization is impossible. Another way to verification that this quadratic equation contain complex 0 is using the discriminant b squared minus 4ac. By the way, this is the same expression that we have inside the quadratic formula, So actually, either way, but I prefer quadratic formula because I give directly what is the zero. Entonces A is 1, B is 6, and C is 12. Entonces minus 6 plus or minus square root b squared is 36 minus 4 times 1 times 12 divided by 2 times 1. Okay, let's focus on the expression inside. The expression inside here, we're using another color okay, is 36 minus, entonces 12 times 4 is 48, ¿no? Let me check it just in case my calculator. Okay, entonces 48. Okay, 48, 48, 48, 48, 48. And this 12, no? Negative 12. Wow, negative 12. Entonces, when you compare the square root negative 12, I know guess I square root positive 12. And leave it like that? No, of course, no. Because 12 is possible. It's possible. Simplification a little bit. 12 is 3 and 4, for example, and square root 16 is square root 3, and square root 4 is 2. Actually, this is 2i, radical 3, no? Radical 3. So these 3 stay inside the radical. However, the 4 no, because 4 is perfect square number. And so far we have minus 6 plus or minus 2i radical 3 over 2. And one more time I split the common denominator because I want to separate the real part, que is minus 3, plus or minus I radical 3. Okay, entonces I am ready, or almost ready, to express the factorization of this polynomial as a linear factor. Linear means degree 1. The first guy is x plus 2, que is a real. This is the easy part. The second, let me try to put it in this way. X minus something, minus c is minus 3, plus I radical 3. It doesn't matter what is the first or second. Remember, this is a factor, and the multiplication, the order is not important. Okay. And leave it like that. Well, you can. However, much better is x plus 2. This is parenthesis, no bracket, because I want to remove this parenthesis. X plus 3 minus I radical 3. And x plus 3 plus I radical 3. End the story. Any question, guys? Super. We are the best in Miami-Dade College. I suppose everyone get 100 points in this test. Well, the other question, okay, this is the one part in blank. I don't know what is the part in blank of the test. But I cannot help the test. You using your imagination. Okay? Okay? So we start today the chapter 3. I can or no? Chapter 3 is very, very interesting. No big deal, in my opinion. Okay, it's about the transcendental function. So this is no rational anymore. This is no polynomial anymore. No, this is transcendental. And the first one, they are a collection of the transcendental function, but the first collection is the exponential functions and the logarithmic function. But first of all, I need to explain two new concepts que is important to understand the exponential and logarithmic. This is my goal. Exponential and logarithmic function. They are a transcendental function. No, it's the only transcendental. We have more in mathematics. We study maybe in another class. But let me try to explain what is the idea behind one-to-one function and the inverse function. So we need that to understand very well the exponential and logarithmic. Okay? Okay, let me recall. In one moment in our subject, we studied the definition for the function. I want to recall definition. For example, we have different situations. We have this situation in which you, for example, associate element in the domain. This is my domain. Okay, this is my range. Okay, x1, x2, x3 with the y1, y2, y3, and suppose that the function associate in that way. So this arrow is the symbolic way to indicate the function, que es the association, but in this case it's obvious que es one-to-one. One-to-one function. One-to-one function. But this is the only possibility. No. We have another possibility que is many to one. Suppose that you have x1, x2, and x3, and we have y1, y2, y3 exactly the same, but you associate in different ways. You associate like that. This and this and that, and suppose this and that. Okay, this is typical. Okay, again, repetition, this is domain, this is a range. But this is many to one. Many to one is also function, right? There are no violation of the function. Remember, we have violation of the definition of the function when we are doing in this way. Okay, domain, range. We have 1, 2, 3. We have 1, 2, 3. But you, for example, create this association. Suppose x1 is associated with the y1 and y2. The rest is not important, but you see it's one to many. And one to many, when you see many in the range, this is no function. No function. Okay, I suppose you remember very well this. Yes or no? You remember or no? Now, one to one and many to one is also a function because you have only one guy in the range. It's the most important idea behind the definition for the function. But what is the problem now? Wow, the problem now is inverse function. This is very, very intuitive idea. Inverse is the operation in opposite direction. There are many examples of the inverse function in mathematics. For example, addition, subtraction. So when you, for example, you pick one number, x, and you add in 10, okay? You get one result. So when you subtract the 10, suppose now you subtract the 10, gets the inverse operation on those each other, and the answer is x. Okay, we come back to the beginning. And suppose 5 plus 10, 15, minus 10, 5. We come back at the beginning. This is the inverse. Inverse of the addition is subtraction. Inverse of the multiplication is division. Inverse of the square is a square root. For example, you pick one number, 25. 25, no, 5. 5 much better. 5. And you square 5 is 25, no? And you apply square root again, que es inverse function, we come back at the beginning. Entonces es interesting que when you apply the inverse function, you come back at the beginning, okay? It's on those each other. So the composition, the function f, and the inverse function, que by the way, the notation that we are using to denote the inverse function is like that, f and -1. But this -1 guy is no exponent. No, this is symbolic way to indicate inversed. It's no exponent. So no, don't interpret que this -1 is 1 over f. No. This is inverse. And what is the interpretation for inverse? Well, the interpretation for inverse is in opposite direction. And opposite direction, I come back to this diagram. Look, it's in opposite direction. In opposite direction. So the arrow change the direction. Okay, the arrow change the direction. This is inverse. But in the one-to-one function, everything is okay. Because when you flip that, one-to-one and in opposite direction is also one-to-one. However, in the many-to-one, we have big trouble. Because when you flip it, now we go to the one-to-many. Okay, conclusion, no inverse. No inverse, en many to one. Entonces, the function, in order to have the inverse function, must be 1 to 1. This is the first requirement. So, and the problem we are doing now, you need to check it out. If my function is given in the problem is 1 to 1. Si the function is not 1 to 1, you say, no, professor, no. Entonces, it's not 1 to 1. Therefore, it's impossible to find the inverse. So the first requirement that you need to satisfy in order to find the inverse function is that the original function gets given is 1 to 1. Okay? And how do you know que es 1 to 1? In the real life, what is the practical test to verification que es 1 to 1? Bueno, I suppose que you remember very well the vertical line test. Yes or no? Vertical line test is the test que allow me verification if the graph of the one specific or hypothetical function is or is not function. Suppose that we have this curve and you apply several hypothetical vertical line and see crossing only one point, entonces pass the test. This is the graph, is a function. Suppose another example like that. It's a parabola, but a parabola que open to the right. When you apply a vertical line test, fail the test, no function. So we have another test, que es no vertical, horizontal line test, que es using to verification if the function is or is not horizontal line test. So this test was using to verification si es a function or no. Function or no function. This is using in another sense is 1 to 1 or no 1 to 1. Okay? Entonces, this is the horizontal line test, que es similar. Es similar idea. Look, suppose that we have a function like that. Okay, this is the typical cubic function, right? And suppose that we have the parabola, que es a square function. Entonces, you apply now hypothetical horizontal line. Si crosses one point, es 1 to 1. Si crossing 2, no. Fail the test. Bueno, professor, but you explained at the beginning que square power 2, the inverse function is a square root. Yes. So what is the reason que it's not 1 to 1 and have inverse function? Well, because you enforcing restriction. Look. For sure, the function f of x squared is not 1 to 1. However, if you introduce some restriction, you put here a semicolon, and you put restriction here, x greater than or equal to 0. What mean that? I don't understand what is that. Well, this is the restriction of the domain. Okay, entonces si I doing the graph of the new function que have the same mathematical expression, however, I enforcing que the domain is only positive 0, in that moment we have a half of parabola, not the entire parabola. And si you apply now the horizontal line test, pass the test. So that function is 1 to 1. Therefore, that function is invertible. So the inverse function exists. This function, no. So the inverse function of this do not exist. Do you understand the idea or no? It's confusing or no? So I can manipulate. Remember that when we study the first part in the function, the definition for the function is not only the mathematical expression. The function is x squared or x cubed. No, 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 no. You define domain and range. And when you define different domain and different range, we have different functions, even though the algebra expression is the same. Okay? Do you understand or no? No? Confusing? Yes. Okay. Okay, guys. Let me try. I bring several examples to illustrate. Wait. I forgot something. I forgot something important. Okay. Remember the inverse is you interchange. Basically, you interchange domain and range. In other words, you interchange x and y. Interchange. So, for example, this is the domain. Let me make a zoom to see that part. This is the domain of f. And this is the range of f. Pero en the inverse, que es the blue color, now, this is now the domain of the inverse because you interchange. Now, this is the first. So now this is the x because you interchange x and y like that. Now, this is the range of the inverse. Now, super important. Let me copy here. Important theorem. Extremely important theorem. Okay, we use it every day so far. Okay. The domain of the one hypothetical function, okay, one-to-one, of course, is equal to the range of its inverse. Look at that. This guy is equal to this guy. Likewise, the range of the region is equal to the domain of its inverse. Keep in mind this, please. Important. Wait. Inverse. This is -1. This is only 1-to-1. Yeah, of course, absolutely. Que the only possibility que is invertible. See, okay, if our function is not 1-to-1, forget about. Okay, suppose in the test I put one example and the function is not 1-to-1. You said, Professor, I cannot do anything because this function that you give me is not 1-to-1. Therefore, it's not invertible, and in the story, I finish. Okay? Of course, I am not stupid. Yeah, I don't put this example in the test, no? I put example in the test case, yes, actually, they are invertible functions. Please copy this idea because it's important. The statement inside the box is important, and we are using now in the example. Okay. Zoom up, out. Boom. Boom. More clear? May I erase the board? Yeah. Okay. Let's move on to the example 1. The example 1. Okay. We have 5 steps. Step 1, 2, 3, 4, 5. Okay, it's given one function, f of x equal, suppose, x cubed plus 3. Okay. The step 1 is determine if that function is 1-to-1 or no? Allocation. Okay, no. Some people want to talk to me. I am teaching now. Hello. Okay. What is the tool that we are using? What do you think? Is 1-to-1 or no? What do you think? Yes, it is. Why? Because it's QB, absolutely. It's QB. Okay. Listen to me. It's QB. This is my, okay, the only possibility to determine si es 1-to-1 or no is with the horizontal line test, ¿no? Y I know que QB function, you know, is like that, the original QB function. And plus 3 is only the transformation, que you know very well. It's a vertical shift 3 unit up. 1, 2, 3. So at that point, que normally is 0, 0, now is 0,3. And this is the x cubed plus 3, no? And when you apply the horizontal line test, es obvio que pasa. Crossing only one point. Entonces the answer is yes. And we start the problem. Okay? Now the graph I provide you, okay? You do the graph in decimals and you analyze. But in this case, it's obvious it's cubic, no? Another more complicated, I don't understand anything. But in this case, it's cubic. Okay, super. Everyone follow me so far? Step 2. Well, step 2 is the most important step. It's determine to find the inverse function equation. Find the inverse function equation. Okay, in other words, what is the equation for this guy? Because I know that the function is this. But what is the equation for this? It's easy. It's easy. The only thing that you should do is interchange x and y like that. This is the most important thing. You copy the original, but the original I replace f of x for y. You know, in the function notation y and f of x is the same thing, right? There are no problem. It's possible doing that. Now, this is a moment to interchange x and y. Now this is x and this is y. Voila! I get the inverse function. This is the inverse. But the only problem is in implicit form. Implicit means that y is not isolated. But I leave it like that? No, never. I need to find the inverse. So day one, in this question, you find the explicit. Explicit means that you do something algebra in order to isolate the y, no? So y explicit is when the y is completely isolated. Subtracting 3. And apply cubic root both sides. Cubic root both sides. Cubic root x minus 3 is equal y. And this new y is the inverse function. In conclusion, the answer for this step 2 is the inverse function is the cubic root x minus 3. End the story. And make sense of this or no? Using the intuitive idea for the inverse function is inverse operation. That the original function addition 3 and cubic. And the inverse function subtracting 3 and cubic root. Make sense or no? Make sense? Yeah, making sense. It's completely opposite. However, I propose you now verification. The step 3 is verification that everything is okay or no. Okay, it's the checking part, si es inverse. How you checking the equation? How you checking the equation? Well, you form a decomposition. The composition of the one function and its inverse, it doesn't matter the order. It's unbelievable because in this case, it doesn't matter the order. The answer is identity function. Remember that the action for the inverse undo the action for the original. It's unbelievable. You know, when you study composition, you know very well that in general, F composition G is not equal G composition F. Okay, you can know permutation. However, in this case, in this particular example, this is true. I want to prove right now. Okay, I have in my hand the function f, que es x cubic plus 3. I have the function inverse, que es cubic root x minus 3. For example, I want to find the composition. The composition is f, composition f inverse. For example, that means that this expression, que is the first one, look, and the order of the composition, the order is important. The first one is inverse function. Substitution here. And we have cubic root x minus 3 raised to the cubic power plus 3. Do you understand the thing I am doing? Do you understand the thing I am doing? Okay, I take, Jasmine, I take the entire inverse function and replace in the x of the original. Okay, I know the cubic power and cubic root undo each other. We have x minus 3 plus 3. Cancel out this 3. The answer is identity function. X equal R is identity function. Okay, this function, identity function. Otherwise, if we are doing in opposite direction, okay, it's completely different. Look, it's like you take the original and substitution here and the inverse function. So you have cubic root, no x anymore, x cubic plus 3 minus 3, no? This minus 3 is this. Oh, similar. This is cancel out. We have x cubic root of the x cubic is obvious x. On those. Important. This is the checking part of the equation for the inverse. Pass the checking, because when I form the composition, the original and the inverse I found in the step 2 undo each other. However, exactly we expect. Okay, now the step 4 is domain. Domain of f. Range of f. Domain of inverse. And range of inverse. Okay, I come back at the beginning. My function, my original function was x cubic plus 3. What do you think is the domain of this? Using your common sense, according to the thing we studied in college algebra, here in MAC1106. What does the agreement when you face the problem of the domain in algebra? What does the agreement? The agreement is the domain is all real number except the restrictions. And restriction we have in three situations, no? And their combination. When you have denominator not zero. When you have radical, pero radical index even, o sea, square root, for root, que the expression inside must be non-negative, because a square root negative number, you know, is imaginary, no? And their combination. We have division, no? We have square root, no. Therefore, the domain is a real number. Domain of this is a real number. And domain of f is equal to the range of the inverse. You remember the theorem that we studied at the beginning? However, what about the range? Look at the graph. The graph looks like that. 1, 2, 3. Something like that. X, Y. It's obvious that when you're projecting any point on the curve onto the y-axis, we get again a real number. Entonces es a real number. And the range is equal to the domain for the inverse. In this case, there are coincidences. For set is the same. Not always happen, but in this case, yes. Okay. The last part, step 5, is very, very interesting. Step 5. Step 5 is the graph. Let's do in the graph step 5. Let's do in the graph of both the original and the inverse. But let's do it in one super easy way. After we are doing decimal, no? But okay. Let me try to do my best by hand. Okay, this is the graph of the original. The original was y equal x cubed plus 3. 1, 2, 3. This point is 0,3, and the graph look like that. Approximately. We need at least 3 points. When it's a curve, we need at least 3 points. For example, we have 1 point here, get 1. 1, plugging in 1 here, is 4, 1,4. Okay, and -1. So basically, we use always these 3 points. 0, because it's easy. 1 and -1. -1, when you plug in -1 here, -1 cubed is -1, is 2. This point is the point -1,2. Okay, and this is the graph of the y equal x cubed plus 3. Now the inverse. This was the original. Okay, now the graph of the inverse. We are doing 2 different ways. Using our knowledge about the transformation, and after the new way I want to explain now. Okay, but let me try by transformation. I know, I remember something. I remember when we studied the function, that the function f of x equal cubic root look like that. Wow, it's different to the square root. The square root is only like that, one piece, because in the negative part it's imaginary, and imaginary do not exist. However, cubic root, no. Cubic root accept negative number, because for example, cubic root -27 is -3, because -3 times -3 times -3 3 times is -27, que is exactly the number that we have inside the radical. Entonces, the cubic root is nice. The square root is figgy. I don't like this girl. However, this I love you because I said any, no restriction, no problem. The domain is a real number, exactly we predict in the step 4, no? So basically, we can interpretation when you're subtracting 3, look at that, when you're subtracting 3 inside, this is horizontal shift, 3 units to the right, no? 3 units to the right. Okay, entonces, one roughly idea how it look like the graph of the inverser is in 3, 1, 2, 3, like that. Right? This is one way. However, I want to explain another fantastic way. Remember, guys, the thing that we are doing is interchange x and y. And this is the way we are doing the most complicated function. Therefore, si you interchange x and y, this point, que normally is 0,3, and the inverse would be 3,0. 2, 3. Okay? This point is 1,4, and the inverse would be 4,1. And this, likewise, this is -1,2 would be 2, -1. 2 and -1 is here. This point is the point, 2, -1. Now the inverse look like that. Let me show you. Let me try to do my best. And you can see, wow. Okay, this curve, the inverse, this is the inverse. Is symmetric with respect to the line y equal x. Okay, this represent the identity function. So this is super important property. Super important property. The graph of the new one is inverse, is symmetric with respect to the line y equal x with respect the original function. Let me see more clear in Desmos this graph. Let me try. Okay. Share screen. Desmos. Okay. Do you see Desmos? Yes or no? Okay. Example number 1. Look at that. Bang. Okay, this is my original in black color. 3 point, bang, bang, bang. This is my new one in green color. The inverse is inverse. And the point, bang, bang, bang. And how you get that point? Easy. Interchange x and y. And this is the famous line, y equal x. Any question? Any question? Super easy or super hard? Super easy or super hard? Let me know, guys. Kinda easy. Kinda easy. Okay, but I want to complicate more your life. This is my first example, and the first example is always straightforward. I want to complicate a little bit. Okay, there you go. Let's move on to example 2. Example 2. Okay, example 2 is, let's see, f of x. This is easy. Equal x squared, semicolon, x greater than or equal to 0. So when I write the test, something like that, the students say, wow, professor, what the hell is that semicolon x greater than 0? This is a restriction, no? This is a restriction because the original parabola without restriction look like that. Therefore, this is not one-to-one. However, when you introduce the restriction, we have a half, the positive half of the parabola, and this, yes, pass the horizontal line test perfectly, and it's one-to-one. que es the first step. Determine if it's one-to-one. Entonces, the answer is yes or no. ¿Es one-to-one o no? In the step one. ¿Es one-to-one? Yes or no? Yes. No. Dice Alain, dice no. Okay, Alain. This is no one-to-one. Pero dice yes. So when you introduce a restriction and you see 1/2 of parabola, this new form, okay, sorry, the restriction make it yes. Okay. Now, the second step is determine the equation. The equation, remember, this is my f of x equal x squared. You replace x, f of x for y, sorry, and now you interchange x and y. This is the most important. That is the reason I put inside the box. This is x equal y squared. And this is the inverse function, but an implicit. And never you write an implicit. You solve for y. You apply square root both sides. Square root x. Square root x equal new y. And this new y is the inverse function. In conclusion, the inverse function is no surprise. It's obvious, it's straightforward. It's a square root. So the inverse function for the square power is the square root, no? But I don't understand one thing. Professor, normally when you apply square root, you put plus and minus, plus and minus. You put plus and minus, yes or no? What do you think? Yes or no, plus and minus? No. And the reason is clear. Remember the restriction. Only positive. Good, very good. The step 3 is verification. So you are doing the composition in different order, and the answer should be identity, because the action for the inverse and the function original together endoss each other. Let's do it. Let me go over here. F of x is x squared, and the inverse is, we get is square root x. I want to verification that this is true or not. So, for example, in that order, the inverse is this guy go inside here. So we have square root x squared. It's so big as x. In opposite direction is the inverse function, the original, sorry, go inside here. Entonces es square root x squared. Again is x. Identity. Okay. Verification. Perfectly. Let me try domain. What is the domain of the original? Well, domain, let me list in here. Domain of f. Range of f. Domain of inverse. Okay, we have 4 sets. Range of inverse. Okay. What is the domain of f? Let me recall. The definition for my f was x squared semicolon x greater than 0. This is the domain. Now the domain is, si you want to express it in interval notation, is bracket 0, infinity. And this is exactly the same of the range of an inverse. You copy, and paste here. Because it's the same. However, let me see what happened with the range. For example, for me, it's a little bit hard. Find the range. Range always is hard. Well, it's harder than domain. Domain is easy. Okay, domain is easy because, for example, I go to the equation for inverse. The equation for inverse is a square root. Entonces super easy identification que the number inside the radical, que es x, must be non-negative. Wow, this is exactly the same of this. O sea, in this case again, every domain and every range is the same. Good? Now I want to see in Desmos. Okay, good, very good. I want to see the graph in Desmos. I don't want to watch the time and do it behind, no. Because my graph is not good. It's not elegant. However, in Desmos, yes. We are very elegant. Let me try to switch into Desmos. Switch into Desmos. Okay. Do you see Desmos? Okay, that was example 1. Now we have example 2. Look. Wow, example 2 is, look. Example 2 is, okay, look at that. I put the original, look at that, look, the original function in blue color. I put a square, but I introduce the restriction, extremely important, to be 1 to 1. So you open curly bracket, x greater than or equal to 0, and this is 1 to 1. Now the inverse function is a square root we found, look at that, and the symmetry with the line y x. And the typical point 3.800, 1, 1 is the same for both graphs, but 2, 4, because 2 squared is 4 and the square root 4 is 2. You interchange x and y. End the story. We are the best. Let's do one more example. Let me see what time it is. One more or 2 more maybe. And stop. Too much. Okay, I will go back to the whiteboard. Boom. Do you see whiteboard? Good. This new example 3 bring me a new important thing. Example 3. Okay, there you go. This is f of x equal 1 over x plus 1. This is like a rational expression. Degree 0 on the top, degree 1 on the bottom. Entonces day 1 que you apply everything. You apply determine si es 1 to 1 or no. Determine the equation for the is inverse. Verification using the composition. Determine domain and range. And finally do the graph. But by curiosity, this function is given. There are no restrictions, no semicolon here to specification. No. Okay, I suppose que no restriction. So the graph is exactly the same. I remember this is the rational function, and this rational function have a vertical asymptote. Yes or no? What do you think? We have vertical asymptote. Yes or no? At what value is the vertical asymptote? You don't remember vertical asymptote? In the rational function, this is the rational function. Answer me. Come on. Nobody know that? And what about -1? Very well. At x equal -1. Where come from that? You take the polynomial in the bottom, q equal to 0. X plus 1 equal to 0. -1. Okay, this is the way. And what about horizontal? We have horizontal, yes or no? Yes or no? Horizontal, yes or no? Horizontal, yes or no? No, yes, no, yes, yes, no. In the cake, yes. Yes. At what value align? At what value? At what value? Y equals something. 0. Very well. Because it's a special case. Okay, super. Very, very well. This is just to understand a little bit. Okay, so now our graph, after we've seen Desmos, but I have roughly idea how it look like my graph. In -1, we have vertical asymptote. In 0, we have horizontal. For example, 0 is positive. Does my graph look like something like that? I guess so, right? I guess so. I guess so. Using my imagination and common sense. So yo evaluate, for example, that point que 0x equals 0,1. This point is 0,1. So now, the first step que determines is 1 to 1 or no. What do you think? 1 to 1. Yes or no? What do you think? 1 to 1 or no? Yes, because pass perfectly the horizontal line test. 1 point. 1 point. Yes. Therefore, the conclusion is that function have inverse function. Here's the thing I try to find. I try to find the inverse function. So the step 2, que es the inverse function, well, let's do it. This is y equal 1 over x plus 1. I copy the original, but I replace the function notation for y because it's more comfortable for me. Interchange x and y. Entonces you have x here, 1 over 1, y plus 1. Voila! This is my inverse, pero no en explicit. I need an explicit. Okay, I try to use my skill in algebra to isolate the y. Entonces I propose you consider like a proportion, cross multiplication, you multiply x times y plus 1 equal 1. Okay, now I remove the parentheses. xy plus x equal 1. xy is equal 1 minus x divided by x. Y is equal 1 minus x over x. And this is my new y, and my new y is the inverse function. Let me copy here. The inverse function is 1 minus x over x. Okay, super. Everyone follow me? Everyone okay, good. Entonces, in that moment, I realized again, this function is a rational function. Yeah, it's a rational because in the top we have polynomial degree 1, in the bottom we have polynomial degree 1. It's a rational function, no? Entonces we have maybe vertical asymptote and horizontal asymptote. What do you think? We have vertical asymptote or no? We have horizontal asymptote or no? Help me to understand this. We have vertical asymptote or no? Yes or no? Vertical. Y at what value? Si the answer is yes, at what value? Yes, good. At what value? I don't see. -1. No, 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 no. No -1. Remember the formula. Ah, okay, okay, okay. Okay. Es 0. Es 0. Es 0. The baric acid is 0. Es 0. And y is, what do you say? 1 or -1? 1 positive. No, 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 no. No, why no? Remember, when the degree is the same, degree of the top is 1, degree of the bottom is 1 again, okay, is 1. When the degree is the same, yes, we have what value? The value doing by the division of leading coefficient. Leading coefficient here, -1, look at that. And this is +1, and -1 divided by +1 and -1. And compare this statement and this statement. Okay, sometimes happen that we interchange the value of the baric acid. So the original baric acid is -1, but this is -1 now, and the inverse would be the horizontal. So it's like interchangeable, the baric acid and the horizontal acid. This is important, you know, right? One more important. Okay, everyone follow me so far? Everyone follow me so far? Yes or no? See, yes or no? Let me know now. Yes, okay. Now, let's move on to the next step, que es determine domain. Domain of F. Domain of F. Domain. Bueno, no, sorry, coño. Let's do in the verification of the composition. Okay, I want to verification if F composition F inverse is identity or no, and different order, like that or like that. Okay, let me copy. The original was 1 over x plus 1. The inverse that we found, okay, need to check in, is 1 minus x over x. Okay? I need to verification. Suppose that we are doing in this order, in which you consider this is the first function, and this is the second, no? So this is the first. See, this is the first. Use substitution, this expression here. So we have 1 over 1 minus x over x plus 1. Everyone saw the thing I am doing? Everyone saw the thing I am doing? Good. Now I want to condense in this and this together using one common denominator, que es x. 1 minus x plus x. And the top is 1. And this is cancelled. So we have 1 over x, que es recíproca, que es x. Boom. We prove que es identity. In opposite direction. In opposite direction is this expression. Substitution here and here. Okay, it's doing. It's 1 minus 1 over x plus 1 divided by 1 over x plus 1. Something like that. Okay, I want to condense in the top part using common denominator, que es x plus 1. So we have x plus 1 minus 1 divided by 1 over x plus 1. This one and this -1 is cancelled. We have x over x plus 1 divided by 1 over x plus 1. And this is a complex fraction. You copy the top expression exactly the same time, flip it. X plus 1 over 1. It's cancel out, and the answer again is identity. Because our inverse that we found before It's perfect, work perfectly on those to the original function. Okay. Let me try now to find the domain and range, and after we see the graph in Desmos. Okay, domain. Okay, domain of F. Range of F. A domain of inverse and range of inverse. Okay, to determine that, I want to see one more time the graph that we are doing by hand. It was okay, acceptable. Look, this is X, this is Y. Remember the original function f is 1 over x plus 1. If we determine a -1, we have vertical asymptote. Yes, vertical asymptote is undefined, -1. And we have this is vertical asymptote, and horizontal asymptote is in y0. Our graph look like that. Remember the famous point 1 here, passing through this and this. So it's obvious. It's obvious that the domain for that function, the blue function, is all real number except -1. So the -1 is the bad guy. Okay, suppose I want to write in this notation case, in my opinion, super easy. X such that no -1. And this is exactly the same, copy and paste the range of the inverser. So the range of the inverser is y such that y no -1. Good. Now, in the inverse function, well, the inverse function was, the expression was 1 minus x divided by x. Entonces es obvio que the restriction es en 0. Entonces es the domain of the inverse x such that x not 0. Because division by 0 is undefined, and this is exactly the range of the original. And make it sense, because this is the horizontal asymptote, and the curve never touch, so the value 0 is totally illegal for the original function. This is the original, and this is the inverse function. Any question, guy? Any question? No? Okay, where's the rest? One of the rests is do the graph. Of course, I want to use in Desmos, no? Because I like Desmos. Okay. Example 3. Okay. Let me switch into Desmos. Desmos. Okay. Suppose you see Desmos, right? Look at that. This is the example 3. Example 3. Example 3. I put the original. This is the original. Do you see Desmos now? Yes or no? Please. Come on. Yes. Okay. I do only in red color the original. You can see clear like water the vertical asymptote at -1 and the horizontal asymptote in y0, no? Boom. Now let's do in the graph of is inverse. Is inverse, the graph is like that. Bam. Okay, this inverse graph have one horizontal asymptote in -1 and one vertical asymptote in 0. And now the famous line gets symmetric. Y equal x can represent the identity. Look at that, the symmetry in between the red, get the original, and its inverse, que es the, I don't know, si es purple color, no? Purple color, yeah. And you see how the asymptote interchange. So the x equal -1, and the original was vertical asymptote. However, and the inverse was horizontal asymptote, que y equal -1, no? And likewise, or similarly, in the original, the horizontal asymptote was 0. Look at that, 0, this line. However, in the inverted, that 0 corresponded with the vertical asymptote, no? Vertical asymptote here, vertical. Do you see how, let me see how the purple curve approached to 0 but never touched. This is typical vertical asymptote. Super, super, super. We are the best. Let me switch into whiteboard again. Do you understand very well the idea behind the inverse function? Why is important? Extremely important, the idea of inverse function, because from next class we start to study one important, super important, extremely important new functions, que es exponential function and logarithmic function. And the relationship between exponential and logarithm are inverse function. So the logarithmic function is the inverse function of the exponential, and the exponential function is the inverse function to the logarithm. And we apply exactly the same theoretical part that we discussed in here. The relationship domain, one-to-one, how you find the one function on using another function, exponential function. But exponential function, the student don't understand very well. Exponential. Today I don't want to start studying exponential. I want to introduce only the name exponential function. Introduce definition. And I present to you one problem. Because you discover the answer, not necessarily you give me the answer now. You have 10 extra points in the test 3. Okay? First of all, definition. Definition of exponential function. Okay, it's a function que look like that. Look, f of x equal a to the x. Entonces a es a number que represent is the base. Is the base. And the base is in general real number, pero no arbitrary real number. Is in general, it is real number. So it's possible que the base is a fraction maybe, or maybe irrational number, or maybe another number, a real number. But be careful, because we have 2 restrictions. The restriction is a is always positive. Okay, base negative is totally illegal. No good. No, this is not exponential. This is another stupid thing. And a is no 0 and no 1. Because 0 and 1 are trivial. Example, because 0 raised to the any power is 0, no? And 1 raised to the any power is 1. This is stupid. So the base, so we can separate the exponential in 2 different exponentials. No, 2 different exponentials. Suppose that if the base is a number greater than 1, positive of course, but greater than 1. And so this is exponential. This exponential is increasing. So this increasing function, exponential. Normally it's called exponential growth. Exponential growth. Exponential growth. Okay, exponential growth. Suppose the example of the exponential growth is 2 to the x, 3 to the x. When the base is a number bigger than 1. However, we have another family of the exponential when the base is in between 0 and 1. Remember, 1 and 0 is illegal. Negative is impossible. So this is the, okay, this is my own real number, look. This is 0, illegal, no. 1, illegal, no. And negative, illegal. So the base lie in this part. Of course, don't include 0, no include 1. And this is this exactly we study now. And we have another case this. And the green part is exponential growth. And the blue part is decreasing, que es exponential decay. It's a decreasing function, decreasing, exponential. And normally in the real life it's called decay. Exponential decay. Exponential decay. Okay. Entonces we study in detail next class exponential growth and exponential decay. Entonces now let me try to present the problem. We have 10 minutes. No necessarily answer me that problem. You think about, and the student can get the answer of this, have 10 extra points. Suppose that we have, look at that. Suppose that we have, this is the extra credit problem. Maybe some smart guy, because I know that you are a smart guy, get the answer, but you stay quiet. Okay, you email me with the answer and that's it. And no share with another student. Okay, extra credit problem. Okay, suppose that we have one box. Let me use my skill in 3-dimension sketch. This is one box. And inside the box, I put the coronavirus. Only one coronavirus. What color is coronavirus? Green. Okay, this is now, right now. One coronavirus. Number of coronavirus, 1. And coronavirus increasing exponential. So we have, this is 0 minute. We have 1 coronavirus, only 1. Suppose that the rate of the exponential is to duplicate. Suppose that at t equal 1 minute. Bueno, es obvio que at t equal 1 minute, we have 2 coronavirus, right? Makes sense, right? Hey, everyone follow me or no? Okay. This is the exponential function. Okay, you have no idea how increasing super faster. Okay, how many coronavirus we have in 2 minutes? How many? How many coronavirus in 2 minutes? 4 coronavirus. How many coronavirus we have in 3 minutes? How many coronavirus we have in 3 minutes? 16, no. Duplicate. 8, 8 coronavirus. How many coronavirus we have in 4 minutes? 16. How many coronavirus we have in 5 minutes? 32. Very well. Okay, how many coronavirus we have in 6 minutes? Duplicate, always duplicate. Super. You understand a little bit exponential function. Now, suppose que I'm waiting a lot of time. I'm waiting. Y in 1 hour, the box is completely full of coronavirus. No, so what means completely full? Well, completely full means that we have 100% coronavirus and 0% empty space, air, no more. Suppose that we have 1 minute more, and I suppose that the box is a science fiction box explode. Or no explode. So in 1 hour plus 1 minute. Explode or no necessarily explode is cloned in 2 boxes or 3 boxes. You know, this is science fiction, but this is after the extra credit. I need to investigate here in the middle of the process at what minute we have that situation. Look, the situation is, this is my famous box. But in this situation, we have some coronavirus, not completely full. But the proportion is 50% coronavirus and 50% air. This is the extra credit. At 1 minute, happen this situation. No answer now. Thinking about that, email me the answer, and you have 10 extra credit points. And curiosity for another student. What happened in 1 hour and 1 minute? What is the situation here now? Suppose science fiction box, okay, this no explode, sino cloning in 2 and 3 and 4 and 5 boxes. And what happened in 1 hour plus 2 minutes? No answer. We email, email to me the answer. 1 hour, 2 minutes. What happened in 1 hour, 2 minutes? And that's it, because the rest is similar. Okay, the extra credit included. This is the most important question, the most important answer, and it's a complementary. Okay, this is 10 point, this is 5 point, and this is 5 point. And you have only one opportunity. You make a mistake, wrong, 0 point. Okay? Okay, guys, too much for today. I'm leaving because I need to prepare another class. Okay. Wait. Okay, stop sharing.